Hi learners, this is Pushkala and we are going to see Numpy image pre-processing techniques. So for proceeding, we will need three libraries. We'll start by importing those. So first is Numpy library. And the second one is to show the images and everything, I need matplotlib. And finally, fill library, pillow. So most of the images importation and image operations can be performed with this pill library. So I'll be importing that for image reading purpose and resizing purpose. Okay, I have imported these libraries. So now we are going to read one of the images using matplotlib. So in matplotlib, we have a image library called imread, which is image read library. So in this, I'm gonna just give the directory of the image. So in this, I have the image in the same directory as this one, this Jupyter file. So I'm just gonna give the file name alone. So if you wanna show the image, just printing img will not do. So it will give me an array. So since I don't wanna see it as an array, I wanna see it as colors. I wanna see it as an image. So for that, we'll be need to use PLT library again to show. So image show library will compose all of that array into one image. So here we are seeing the image of the dog. So this is the image I have imported. So we can do any normal processing we do in an array using this. So let's say in an array, we usually do n dimensions. You can check for dimensions using n dimension. 3. Dimension is 3. Print img dot shape. Shape is this image is actually 1080, which is the y-axis. 1080 is the y-axis, and the x-axis. Basically, we'll say rows and columns here. So the first one is rows. So we have 1080 rows, and the second is columns. 1920 columns. So 1920 column of pixels, and 3 is nothing but RGB channel, which is given as 3. So this has combinations of red, blue, and green, which has 3 dimensions. That is why we get 3 over here. So again, if we want to check the type of this array, type of the image, D type, we get unsigned integers, because whenever I just print image, you get a bunch of integers as arrays here. So the type of each number inside is actually unsigned integer of size 8. So this is all the basic manipulations we do in array that can be applicable for image arrays as well. So what happens if I want to resize the image? So we'll go by one, resize the image. So let's say the pixel of this image is too high. The pixel of this image is actually 1080 cross 1920, which is higher for identifying whether it is a dog or not. So let's say I'm gonna resize this image. So I'm gonna resize this image into 128 cross 128. 128. I'm gonna resize the original image into this. Here we are going to change this image into 128 cross 128. For this, I'll need this pill library. I'm gonna use this pill library to do the same. So what I'm gonna do is, let's say image2 equal to np.array of I'm gonna read with the image library. The image library that I have installed, imported from pill library in here. So image function, in that I'm gonna say open the file. Open the file dog. So done. This will just open the file. Whereas to resize, I'll just use the code here itself. Resize 128 cross 128. That's all. So if I use imshow.img2 here, you will be seeing the resized image here. Okay, I missed one brackets. Okay, no. Okay, yes. So this is the image that is being resized. So this is the original image, whereas you can see the quality of that image is very high. Whereas I have reduced the quality of this image. Still, all the necessary information from that particular image has been recovered. To identify whether the given animal is dog or not, we will not need 1000 cross 1000 etc. pixels. We need only hundreds of pixels. So with only 128 pixels cross 128 pixels, we will be able to identify what image that is. So for that, this pre-processing is really helpful. So while you go for neural networks or a huge image classification or object detection programs, your image size has to be reduced. Whenever we have a higher image size, this computations might take so much longer. So it has so many unnecessary details as well. So learning that would be useless. So in that case, we can do something like this. Resize the image into pixels that we minimum required for classification, and then we feed it to the computer. That is where pre-processing of image for resizing comes into picture. And the next is going to crop. I'm going to crop this image. This image has a lot of landscapes and I have a lot of empty spaces in here. I want just the image of the dog. So I'm gonna crop this image into the necessary pixels alone. So using Numpy, we usually do array indexing. Using this array indexing, we can actually make sure we can segment this dog image alone. So I'm gonna do that. plt.imshow, or I can just do another image. In this, I'm gonna use the image too. As you can see, the dog starts by maybe 15 or 17 and ends with the row of 120. So I'm gonna just say 15 to 120, comma. The columns is 45 to 85. 45 to maybe 80 is also enough. 80. I am show of image 3. So as you can see, we have splitted the pixels from only one image. I have splitted all the unnecessary details from the image and cropped the image, only the dog pixels appear so far. So in image 3, only dog exists, nothing more. This is actually just a simple array indexing, nothing more. Using array indexing, you can manipulate the images, crop the images as well. So we'll continue this in the next part of NumPy image processing video. Thank you.